Hello everyone, and welcome to this discussion video about block diagrams. Before I begin, I would just like to extend my gratitude to my group mates who extensively did research and compiled all their efforts and knowledge into making this presentation. So in this video, I will be the one explaining the various topics involving block diagrams. And if you want a copy of this PowerPoint presentation, just message us. And I would also like to point out that this is a semi-interactive presentation. Now that these are out of the way, let us start. So this video will cover various topics like what are block diagrams, why are they important, knowing the basic elements of block diagrams, tips on making block diagrams, and block diagram reduction. So now, let us determine what is a block diagram. So as stated here, a block diagram is a drawing or illustration from a system whose major parts or components are represented by blocks. So from this definition alone, we now know that one of the major parts or the major components will be blocks or will be boxes. So one thing comes to mind, are all boxes block diagrams? What really makes a block diagram? So I hope that we will know the answer at the end of this discussion. So another definition would be that a block diagram is a pictorial representation of a control system showing interrelation between the transfer function of various components. So in other words, a block diagram will show the relation between each block and each component, so it will be much easier to understand the process. So another definition is that block diagram representation is used to build a mathematical model of a control system which can be emulated on a computer. So the last definition is a block diagram representation is used to calculate the overall transfer function. So we have this word transfer function and block diagram representation. We will tackle it as we go on with our discussion. So these are just some of the basic definitions of what a block diagram actually is. So now that we know what block diagrams are, let us proceed to determining why they are important. So right here. So why are block diagrams important? So block diagrams are generally used when the visualization of information or control flow is important, or when processes are involved. So in this way, we can represent complex algorithms or flow of information or communication among individual components within a large system. So as we all know, a graphical or pictorial representation of something is much better than the textual or written format. So much like we want things that we can see rather than hearing those things. So another way to put this is we are certain that something is true if we see it or it is proven right before our very eyes, rather than listening to it or just reading it in a book or a text. So I don't know why, but I guess that's just us being human. So another reason why they are important is that a block diagram is an essential method used to develop and describe hardware or software systems as well as represent their workflows and processes. So block diagrams are used in electronics to represent systems and their shifting. So another definition would be it is a fundamental way that hardware and software developers utilize to describe their systems while illustrating their workflow process. So this is just the same as the definition before. Or another reason why they are so important is that they are of great assistance when a clear picture of information or control flow is required, besides when a project has a myriad of processes. So another reason is that you will be able to easily decipher the system's details, interface, and such as structure aspects. So stated here are the advantages of using block diagrams to represent a system or a process. So one advantage is that it is very simple to construct. So since block diagrams are mainly made of blocks and arrows and much more, so we will get on that later. So it is just very simple as long as you know the exact process. And another advantage is that function of individual element can be visualized. Individual and overall performance can be studied, and overall transfer function can be calculated easily. So as we see, using block diagrams has great advantages, but the turning point for this is that you need to know the exact process so that you can model your system. Okay, since we have discussed the advantages of block diagrams, so since we all know that there are two sides of the same story, we can determine that using block diagrams have its disadvantages. So one disadvantage would be it doesn't give any information about the physical construction of the system. So since the model would be represented by blocks and not the physical structure itself, it would be hard to determine what type of machine or process that it is modeled out of if you do not have the prior or extensive knowledge about the model. And another is source of energy of the system is not shown in the diagram. So when we talk about models, one thing that can be coined would be the word variables, since using variables in any model would be much easier to understand. And if you are using variables, some people would misinterpret those variables as something else, since they are not well versed in what these variables represent. So now that we have finished discussing the importance, advantages, and disadvantages of block diagrams, so let us now proceed to the next topic, which is the basic elements of block diagrams. So the basic elements of a block diagram are a block, the summing point, and the takeoff point. So these are the three most basic elements of a block diagram. So you can include arrows. So let us consider the block diagram of a closed loop control system as shown in the following figure to identify these elements. Okay, so we have our closed loop control system. So this can be considered as a closed loop since the signal will go from here to here, and it has a takeoff point. So this takeoff point will carry the same signal that will be carried down here, and the signal will go up to this summing point. So the signal will go to this summing point, and the summing point will go from here to here, making it a closed loop. So the block diagram at the left consists of two blocks having transfer functions g of s, and h of s. So it is also having one summing point and one takeoff point. So this is an example of a summing point, and this is an example of a takeoff point. So arrows indicate the direction of the flow of signals. So let us now discuss these elements one by one. So the first one we will discuss will be the block. So what is a block? The transfer function of a component is represented by a block. So if you see a block in a block diagram, so the block represents the transfer function. So this represents the transfer function. So block has a single input and a single output. So the following figure shows a block having input x of s and output y of s, and the transfer function g of s. So here we have input x of s and output y of s. And since the transfer function of a component is represented by a block, so g of s is the transfer function. So here we have the formula of the transfer function. So the transfer function g of s will be equal to the output over the input. Or the output will be equal to the transfer function multiplied by the input. So the output of the block is obtained by multiplying the transfer function of the block with the input as stated in this formula. So now that we know what a block is, we will now discuss the summing point. So what is a summing point? The summing point is represented with a circle having a cross X inside it. It has two more inputs and single output. So it produces the algebraic sum of the inputs. So it also performs the summation or subtraction or combination of summation and subtraction of inputs based on the polarity of the inputs. So let us see these three operations one by one. Okay, so as you can see, this is a summing point. So as stated here, so this is an example of a summing point, a circle having a cross at the center. So here's the first example. The following figure shows the summing point with two inputs, A and B. So we have input A and input B, and one output, Y. So here the inputs A and B have a positive sign here. So the summing point produces the output Y as sum of A and B. So therefore Y is equals to A plus B. So here's another example. So the following figure shows the summing point with two inputs A and B and one output Y. So we have A, B, and the output Y. Here, inputs A and B are having opposite signs. A having the positive sign and B having the negative sign. So the summing point produces the output Y as the difference of A and B. So Y is equals to A plus negative B since B has a negative sign. So if we simplify this, it will become Y is equals to A minus B. So now that we are done explaining the different operations of the summing point, so let us now go to the takeoff point. So the takeoff point is a point from which the same input signal can be passed through more than one branch. That means with the help of takeoff point, we can apply the same input to one or more blocks or summing points. So here is an example. So in the following figure, the takeoff point is used to connect the same input, R of S, to two or more blocks. So as you can see here, this is the signal for R of S. And since it has a takeoff point right here, this signal will also carry R of S. Okay? So this signal will still carry the signal R of S, and this will also be R of S. And to determine the output, as stated in the previous topic, we just need to multiply the input. So as you remember the formula, Y is equals to G of S times X of S. Y being the output, X of S being the input, and G of S will be the transfer function. So the output in this would be R of S, G sub A of S. So the output would be R of S, G sub A of S. See, because the output will be the product of the transfer function and the input. So since R of S is the input and G of S is the output, so the G of S is the transfer function. So the output would be R of S, G sub A of S. So the same rule will be applied to here. So the output would be R of S, G sub B of S. Okay, and this will be R of S, G sub C of S. So here is another example. So here we have the output C of S that is connected in the summing point, which is located right here. Since C of S will be carrying the negative signal, C of S would be negative and R of S would be positive. So the output would be R of S minus C of S. So in determining the output of the transfer function, all we need to do is remember that the output is equal to the transfer function multiplied by the input. So since we have the input right here, all we have to do is to multiply it to the transfer function. So now we can have the output. So the output would be G of S quantity R of S minus C of S. Okay, so just remember the operations for the summing point and this formula in determining the output, and you'll be good to go in solving basic block diagrams. Additional information is that it is essential to understand the terms used in describing the relationships within block diagrams. So these are association. So it explains the communication among the blocks. Aggregation. So this term describes how a unit gets made of parts. Next is composition. It is a proper form of aggregation in which the existence of an object which is part of a unit relies on the presence of the group. And next is the generalization. So it's a leading relationship between blocks in which a designated block contains all the properties of the entire block diagram. So now that we have finished discussing the basic elements of the block diagram, let us proceed to the next topic, which is tips for making block diagrams. How do you make a block diagram? So number one is to study and understand the system firsthand. Or in order to effectively make a block diagram, you need to have a full understanding of the model that you are representing. Okay, so you need to determine the components, inputs, and the outputs. So tip number two is design and mark the diagram. So use symbols intellectually to represent specific parts of the system. So this can prevent people from misinterpreting certain symbols. And always connect the blocks using arrows to show the flow of the process. And naming the blocks is very crucial for easy identification. So tip number three will be show the input and the output. So input will indicate the start and the output will indicate the end of the process. And lastly, tip number four, accuracy verification. Before putting the diagram out there for use, so confirm with a concerned and involved team about its accuracy. So you should all be on the same page regarding the block diagram correctness. So now that we know the tips in making a block diagram, so let us now proceed to block diagram reduction. So block diagram algebra or block diagram reduction is nothing but algebra involved with the basic elements of block diagram. So this algebra deals with a pictorial representation of algebraic equations. So it is normally required to reduce multiple blocks into a single block, or for convenient understanding, it may sometimes require to rearrange the blocks from its original order. For the calculation of transfer function, it's required to be reduced. That is why block diagram algebra or block diagram reduction are used. So just like any other type of algebra, it has its sets of rules. So here are the block diagram reduction rules. So number 1 is combining blocks in a cascade. So what is a cascade? So a cascade will be the same as in series. So rule number 1 will be combining blocks in a series. And number 2 is combining parallel blocks. Rule number 3 is moving the branch point ahead. And rule number 4 is moving the branch point behind. And rule number 5, moving the summing point ahead of the block. Rule number 6, moving the summing point before the block. Rule number 7 is interchanging summing point. Rule number 8 is splitting summing points or combining summing points. And lastly, rule number 9 is the elimination of the feedback loop. So I know this seems intimidating and overwhelming, but no need to worry. We will cover the rules and explain it one by one. So now let us begin with the first rule of block diagram reduction, which is combining blocks in a cascade. So consider this block diagram with transfer functions g1 and g2 with input A. So since we know how to get the output of a block diagram, so all we need to do is to multiply the transfer function from the input. The output in this part of the block diagram would be a g1, since we multiplied a and g1. So now we will go to the next transfer functions. So the input of transfer function g2 is a g1, and to determine the output, all we need to do is to multiply both of them. So the output would now be a g1, a g2. Also, when combining blocks in cascade, all you need to do is to multiply the two transfer functions, as shown right here. So as you can see, we have a transfer function g1, g2, and an input a. So what will be the output? So the output would be a g1, g2, which is the same as the first output. So to sum it all up, when combining blocks in a cascade, just multiply the two transfer functions, and you can have a single block. So it can become much easier to read and understand. Okay, so now that we have covered the first rule, it's time to proceed to the second rule, which is combining parallel blocks. So consider this block diagram with transfer functions g1 and g2. So now we will have an input of a, and since there is a branch point or a branching point from this part right here, it will also carry the signal a. Okay, since it is branching off from a, this will also have a signal a. So the output right here, so the output in this part of the circuit would be a g1. So we multiply the transfer function and the input, and the output in this part of the block diagram would be a g2. Since we have a summing point right here, or a summing junction, and since both of them are positive, the output would be a g1 plus a g2. So we just combine the two outputs to make the final output. Okay, so when combining parallel blocks, all you have to do is to simply add the two transfer functions, or you need to combine them. So here, instead of having two blocks, G1 and G2, we have a single block with a transfer function G1 plus G2. Now to check whether this is correct, we will put the input A right here, and the output would be A quantity G1 plus G2. Now if we distribute A, the output would be AG1 plus AG2, which is the same from the first output. Okay, so to sum it all off, when combining parallel blocks, just combine the two transfer functions, because instead of having two blocks, you can have a single block containing all of the transfer functions. So this is the second rule in block diagram reduction. Also, the most basic purpose of block diagram reduction is to reduce block diagrams. So just like what we did here, instead of having two transfer functions, we reduced it into one. Now that we are done explaining the second rule of block diagram reductions, let us proceed to the third, which is moving a branch point ahead. So consider this block diagram with transfer function G and signal A. Now, as you can see here, we have a branching point branching off from signal A. So we know that the signal in this part of the block diagram would be A, and the output would be, so we multiply the transfer function and the input, we multiply them, the output would be AG. Now you want to move the branch point from this side to this side, so this will be your new branching point. So this is what you have to do. Okay, so first off, copy everything from the transfer functions to the signals and the outputs, since the only one that we will be moving will be the branch point. So we have, okay, so we have a signal A right here. Since we move the branch point ahead of the block G and it is branching off from signal AG, we know that the signal from this branch point would also be AG. And since the branch point that we move has a signal of A, we need to get rid of this G. Okay, so how do we get rid of G? So we can get rid of this G right here if we multiply it from the inverse of the block that we moved it ahead with. So in short, we will multiply it from the inverse, or we will multiply it from 1 over G. Why? Because if you get the output from this part of the block diagram, the output would be A, which is the same right here. So I bet you're confused. Why A? Because if you multiply AG by 1 over G, okay, so the output would be AG over G. And since we can cancel the numerator and the denominator, the final output would be A. So to sum it all off, when you move a branch point ahead of the block, so all you have to do is to multiply the branch point with the inverse, okay, with the inverse of the block that you move it ahead with. Okay, since you moved it ahead of G, you will multiply it with the inverse of G, which is 1 over G. So if this is G sub 2, you will multiply it with 1 over G sub 2. Just remember that you will if you move ahead of the block, just multiply it with the inverse of the block that you moved it ahead with. So now on to the next rule. So the fourth rule is moving the branch point behind. So let us consider this block diagram with transfer function G and input A. So the output would obviously be AG. So since the branch point is branching off from this output AG, it will also have a signal of AG. Now, if you want to move the branch point behind the block, okay, so you want to move the branch point right here, okay, So this is the rule. So if you want to move it, just copy everything except the branch point, since the branch point will be the only thing that will be moved. Okay, so from here, our transfer function G, input A, and output AG. Now we will move the branch point behind the block. So now the branch point is branching off from signal A. So this branch point will have a signal of A. The branch point that we moved has a signal of a G, or has an output of a G. How do we add G from this input? So all we have to do is, we have to add a block G, because when we take the output of this, it would be AG, which will be the same as the previous one. To sum it all off, if you want to move the branch point behind the block, all you have to do is to multiply it with the block that you moved it behind. So since you move the branch point behind block G, you will now multiply the new branch point with whatever inside this transfer function, which in this case is G. So now that we have finished discussing the fourth rule, let us go to the fifth rule, which is moving the summing point ahead of the block. So consider this a block diagram with transfer function G and inputs A and B. So here we have a summing point in this point of the block diagram. So the output in this part of the block diagram would be AB, A plus B rather. So now we will get the output from this part of the block diagram. So the output would now be G quantity A plus B, or if we distribute G, the output would be GA plus GB. So you want to move the summing point from here to here, which is ahead of the block. Okay, so this is what you have to do. Okay, so what did you notice in this new block diagram? Okay, so one thing you have noticed is that you now have two transfer functions of G. Okay, so basically we just split G into two different transfer functions. Why? So this is why. You have from here you have two transfer functions of G, and you have an input A and input B. So the output in this part of the block diagram would be GB, since we multiply G and B. Okay, so, and this part would be GA or AG. They are still the same. So here we have a summing point. So what do you do when you have a summing point? We will combine them. So we combine GB and GA. The output would now be GA plus GB, which is the same as the first output. So we just move a summing point ahead of the block. And this is the resulting block diagram. So in conclusion, if you want to move a summing point ahead of the block, you just split the block that you're moving it ahead with, in this case block G, into how many signals there are. Okay, in this case there are two signals, A and B. So we will split block G into two blocks. So we will split block G into two blocks. One for signal B and one for signal A. Because if we combine them with the summing point, it will have the same output as the previous one. So keep in mind that all you have to do to get this sort of block diagram reduction correct is always check the signals and the outputs. Just be mindful of them and make sure that the final output would just be the same. Okay, so now we have finished discussing the rule and moving the summing point ahead of the block. So now we will go to moving a summing point before the block. So consider this a block diagram with transfer function G and inputs A and B. So from here, we can see that the output in this part of the block diagram would be AG, and this would be B, signal B. Okay, since we have a summing point, all we have to do is to combine the two signals. And since both of them are positive, okay, so be mindful of the signs, the output would be AG plus B. Okay, now, you want to move the summing point before the block. So you want to move the summing point before the block. Okay, so move the summing point before the block. So this is what you have to do. So now we have moved the summing point from here to here, which is shown right here. We have the transfer function G here and the summing point. So as I have said before, checking the signals and the output is very important in understanding block diagram reduction. Okay, so why did 1 over G pop up here? Okay, so we will know as we go on in this rule. Okay, so first we have the signal A and signal B. So from here, the output in this part of the block diagram would be B over G. And this, the signal right here, would be A. And since you have a summing point, you need to combine the two signals, B over G and A. So now you have an output of A plus B over G. So now if you get the output in this part of the block diagram, the output would be whatever this thing is. Or if we simplify it, it would be AG plus B. Okay, which is the same as the previous one. So how did it become AG plus B? So here we have the equation A plus B over G. Now, if you want to get the output, we will need to multiply the input to the transfer function G. So we will multiply it with G. Okay, so now we distribute G. It will now be GA or AG plus BG over G. So we will just simplify this, cancel. So now we will have a signal of AG plus B. So I will repeat this. Signal and output checking is very important in block diagram reductions. So I hope that you understood this rule. It's pretty confusing, but just remember that the most important thing is the checking of signals and outputs. So to sum it all up, if you want to move a summing point before the block, so all you have to do is to just check signals. It's pretty hard to explain, but just check the signals and make sure that you have the outputs the same. The final outputs the same. Okay, so let us now proceed to the next rule, which is interchanging summing point. So now let us begin the next rule, which is the interchanging of summing points. So consider this block diagram representation with two summing points connected side by side, one having input A and input B. Okay, so from here, we know that the output in this part of the circuit would be A plus B. There will be a third new input, which is C. So from here, we will just have to combine input A, B, and C. So the final output would be A plus B minus C. So now you want to change the two summing points. So this summing point will be placed right here, and the other summing point will be placed right here. So this is what you have to do. So first of all, you have to draw the block diagram. Swap the two summing points. So in this case, the summing point containing the positive and negative will be on the leftmost side. Okay, and the ones containing both positive will be on the rightmost side. So here we can see that the two summing points are now interchanged. Now we will put in the inputs A and C. So we put C in here since C has the negative signal. So when we combine A and C, the output in this part of the block diagram would be A minus C. Now the only signal that is left is signal B. So we will put signal B right here. Okay, so now when we combine signal B and the output A minus C, so the final output would now be A minus C plus B, which is the same as the first one. So in conclusion, if you want to interchange summing points, all you have to do is just swap them along with its signals. Okay, so just be mindful of the signs, because as you can see, there isn't much of a change here. Not much is affected if you are interchanging summing points. Okay, so now that we have done discussing this rule, let us proceed to the splitting summing points or combining summing points. So consider this block diagram having three inputs. So these inputs are A, B, and C. Based on our previous lessons or our previous topics, we now know that the output in this part of the block diagram would be A plus B minus C. Okay, so since this is a summing point and A has a positive sign, B has a positive sign, and C has a negative sign, the output would be positive A plus B negative C. Okay, so it's just as simple as combining the three signals. So now you want to split these three input summing points into two summing points having two inputs. Okay, so how do you do it? So now instead of having one summing point, the summing point is now split into two summing points. So when you're splitting a summing point, make sure that all the operations are still present. Okay, here we have signal A and signal B. So the output in this part of the circuit would be A plus B. So now the only thing missing is signal C. So we will put signal C right here. So now the final output would be A plus B minus C, which is the same as the first one. Okay, so in conclusion, when splitting or combining summing points, make sure that all the previous operations are still present so that it won't affect the final output. Okay, so now that we're done, let us proceed to the final rule, which is the elimination of a feedback loop. So I think you're familiar with a loop. Okay, so this can be considered as a feedback loop. The signal will start from the summing point to here, and it will branch off here. And it will continue up here back to the summing point, forming a loop. So in this case, this is a feedback loop. So consider this block diagram with having transfer function g and h, okay, and having a signal or having an input r and an output c. From this block diagram alone, it is pretty hard to determine the output since it has a loop. So we need to get rid of this loop, or we need to simplify this in order to get a proper output. So there is a rule in eliminating a feedback loop. So this is the rule. Okay, so we just turned a complex feedback loop into a single block. So the simplified version would now be the transfer function g all over 1 plus the transfer function g and h. And there are two cases in this elimination of feedback loop. Since the feedback loop will have a negative signal, the operation in the denominator would be positive. It's like the inverse. Now we have another feedback loop having a positive feedback. Okay, so based on the previous rule, so the feedback loop would now be simplified as the transfer function all over 1 minus, okay, so minus since it is carrying a positive feedback, okay, so 1 minus the transfer function multiplied by the feedback h, or the transfer function h. Okay, so let us see if we are correct. Okay, here. You see, so we just turn a complex feedback loop into a single block. So in conclusion, when you are eliminating a feedback loop, make sure that it is a feedback loop. And, you know, just be mindful of the sign. If it is negative, the operation on the denominator would be positive. And if it is a positive feedback, it would be negative. Okay, so now that we have finished discussing all the block diagram reduction rules, this is the part where I have to say thank you. So thank you for listening. And this sums up the discussion all about block diagrams. This was Lord Kelvin Abellana. Goodbye.